I don't know if I'm the man of perfect details, but I do make sure I don't forget things like this. So, hi everyone, and today is going to be a weird day because this thing is completely unscripted, so it may take longer than expected, but let's see. So I did this effect already a year ago, but I did it really quickly and I don't remember much the details. I just know that I know how to do it, so it shouldn't bring any surprises. And let's see how it goes. So here I have just empty file index.html in an empty directory, and on the right we have this um, application running. It's just empty. There is no code here at the moment, and I'm using Google Chrome here. The console is open. My developer tools are open, and then Visual Studio Code on the left. So let's begin and see how this goes. Okay, my keyboard is different and I had to, yeah. So basic HTML in the beginning. And let's write the head section and the body section. Yeah, this keyboard is not the best today, but I hope I get used to it by the end of what's happening. Yeah, let's get this done. I hope it's gonna work out fine. I really didn't look at all at the code anymore from last time. I have some notes here on the right of how some things should be done, but it's gonna work out. I'm not worried. Let's title this page. Say here animated flag. Mm, width color change effect. Well, let's also capitalize these words. Okay, and I'm probably going to just leave the head like that. Uh, let's actually let's put a style here. I'm not going to put extensive styling today. I just want to remove the margin from the body. It bothers me. Like this. And in our body, I'm gonna add here a canvas element. Let's just call it my canvas. And this is going to be where we do our animation. All right. Does this work? Let me refresh. The title here is now animated flag with color change effect. That's good. The page is still white, but there is the canvas here, this my canvas. Uh, you can see it added into this elements right here. I want to set it to be as big as the page, as large as the document. So let's start our script here. And let me just do a quick document setup here, and then we'll move in another file to do the actual effect implementation. So I'm gonna set this canvas width equal to the window inner width, and the same for the height. Let's see. It works, it fills it perfectly. but this browser is adding this horizontal scroll bar, which again bothers me. For some reason it's there now. Let's see how the canvas actually looks like. Let's make it cyan. I want to remove this thing here, this horizontal scroll bar. Yeah, that's good now. So this is now filling my browser screen here perfectly. And I don't want to show the canvas a different color. It's gonna intervene with the color of the flag. No shaders. I'm not very familiar with shaders actually. Maybe I should study them a little bit, but no, I'm not gonna play with them. I'm just going to do a simple particle system and add some constraints between the particles so that they behave kind of like a cloth. And then texturing, but that texturing, no shaders. I'm just going to probably draw some polygons between particles in the mesh to make them different colors. At least that's how I did it last time when I implemented this effect. I hope I can do it again. Okay, so let's say now that with our canvas setup, we are going to, hello, Christian. So I'm going to move in another file now. So let's create a file for this effect. Or maybe not. Maybe we are going to set up the animation loop here as well. Since it's not a very big piece of code, I will set up the animation loop here, and then I'm going to move to a different file where I'm defining the flag object. So let's see. Animate. Animate. Okay, so this is our animation loop. Let's also call it up here. And in it, I want to work with this canvas and clear the canvas and then draw the flag on the canvas. So let's prepare that as well. Let's have here a reference to this canvas. Context. Like this. And here in the animate, I just do the standard thing where I clear the rectangle from the 0, 0 top left to my canvas width, my canvas height, and redraw this flag. So flag, draw on the canvas context. So this flag is the thing that we need to implement. I'm gonna define it here. Let's put it after this canvas part. And it will be a global variable. New flag. And let's start writing this object in its own file. So src flag.js, closing the script tag. So let's create a new file here and a class flag. The constructor is empty for now, and it does have a method here for drawing. So let's write it, draw with the given context. At the moment it does nothing, but this is our starting point here. Right, let's actually try to draw something here and see if it works. Maybe CTX, fill, rect, and then let's say 100 pixels from the top, 100 pixels from the left. I don't know if these are actually reverse. Let's find out. 2 pixels from the top, I think. And then 100 with 100. Height. Let's put here 50 height. Yeah, so this works. 50 height, 100 width, and 100, 200 this offset. So 100 like this and 200 like this. And to see if the animation loop works, because this is just one rectangle, I'm gonna change this color dynamically and say fill style. Let's say RGB, and let's have a value for red and 0 blue, 0 green. Now let's define this red to be a random value between the random gives us between 0 and 1, but if we multiply by 255, this gives us between 0 and 255. And here, let's convert this so we don't get the floating point number. And now when we refresh, we see this rectangle pulsating with the different shades of red there. I think no break, but it depends if I need to use the toilet or something like that. Just powering through to the end. If you think that at some point we need a break, then maybe I can take a 10-minute break. It's up to you. Yeah, the theme song sure is liked by many people and confusing to others. I have mixed feelings about it, but I'm really glad I made it, and I've been using it ever since. First I thought I'd just try it out for a few videos, but yeah, I like it. Random between 128 and 255, sure. That sounds like a job for linear interpolation. Let's implement here a math.js file, and let's write here a function for linear interpolation between a minimum value, a maximum value, and let's use another variable here for the percent. So let's return here minimum plus max minus min times t. If you don't know this linear interpolation function, I do have a video about it somewhere, just search in my collection. And here I'm going to say lerp between 128 and 255 using a random value for the third parameter, and let's keep this integer conversion here. I'm gonna include also this math.js here. So now the shades of red are closer to red, and they never become black. So we have the values between 128 and 255. They are still random values, but the interval is less than from 0 to 255. So I made this math.js file here because I know that I will need more things here. Vector operations, things that I just released last week, a video about vector operations. So yeah. Okay. Keep it. But this is not what the flag is about. I mean, if this is the flag, then no, this is not going to be the flag. But maybe I'm gonna keep part of this code. Who knows? Maybe something will be interesting to be used afterwards. Like maybe we're gonna make the song. Yeah, sure, sure. But let me keep also this part of code because maybe I changed the effect a little bit. Who knows? Maybe the flag is gonna be blinking all over the place. Let's see. But yeah, so the flag is gonna be built of things, and I think that I'm gonna do the typical things I've been doing, like in the when I made this monster for the game that has the tentacles. I used this Verlet integration, and it works really well for moving particles in a fluid way, adding constraints between them, and this is how I did the simulation last time as well. So let's begin with generating some particles, part of this flag. Maybe the constructor will have width and height. And let's set a number of particles for the width equal to maybe, I don't know, 50. And the height 30 or something like this. And I'm just gonna focus with the width now and say here, yeah. Let's generate 50 particles. So and we need to figure out a x and a y location for this. Let's actually wrap it in an object here, so it's the only thing, the one parameter that we give to this constructor. So these particles will be an array. It's initially empty, and then we add more particles to it with this x and y location. The x is going to be something like, let's say we give an offset to this flag, maybe a left offset of 100 pixels. So left plus, and now let's scale I times a value, maybe like a separation distance between the particles. So let's put here separator of maybe 5 pixels and multiply this I by that value for dx. And the y, I'm just gonna put that maybe at the top, and top is also going to be defined here as 100. So generating some particles here, 50 particles, starting at 100, 100, adding them to this array. And then the draw will have to draw these particles. So I'm just gonna write a for loop, maybe particle of particles. So doing a for loop where I iterate through each particle, and then I'm going to say here particle draw on the CTX. So we need to implement this particle class next. It's also going to be able to draw something on the context, and it knows where it is, this x and y. Uh-huh. Yes, coding a flag animation, cloth animation, but it's gonna be styled with some colors, and it's gonna have a possibility to change the colors somehow, like each pixel or patch independently, kind of like this Thanos effect, but it doesn't disintegrate, but it just changes. I don't know how to call it. But if you've seen the trailer for this live stream, then you probably know what I'm talking about. So particle class, let's do it in a separate file. I would like to keep things organized today. Particle.js and particle.js, class particle, and constructor. The constructor had the x and y, right? Yes, but it's like wrapped inside of an object, so I can just call this location for the particle and say here this location is equal to that location. And our draw method, the one that we are going to call here for displaying the particle, it takes the context as a parameter, and I'm just going to use it let's just make it a small rectangle. So fill rect, and the location will be this loc x. Minus size. Let's put here a size for this particle, and let's say it's 4 pixels width and 4 pixels height. And here I'm going to subtract half the size from the x, so that the center point will be in the middle of this rectangle, and then 2 pixels left, 2 pixels to the top. So yeah, and size for the width and height. I think this is gonna work. It's probably done already. Let's refresh. But they are very close to each other. I think I'm going to change these a little bit. Let's change these default values here, maybe just 30, and let's put here the separator to 10. Yeah, this looks good. Let's keep it 20 width and separator to 14. Maybe the separator can be also part of the constructor here, one of the properties that we can send when defining this flag. All of them have these default values, but we can change them in the up the stack. So now if I refresh, it looks like this. But here where I define the flag, I could specify that I want different values for these. The problem is I would need to specify all of them if I need to get to the last one here, for example. So a little better way to do this is to actually write this using this object syntax. So I'm wrapping everything in an object here and doing object destructuring essentially to get these different values back out again. And now if I go back here and I say that I want the separator to be 30, for example, I can write this, and when I refresh, the separator is 30. So in this kind of syntax, it doesn't matter anymore if I pass these in order. They all have default values here, But if I overwrite them, like if I say the width should have just 3 particles, I can do it like this. And it will have just 3 particles on the width. So it's quite convenient in this way. Yes, you can make this in functional way if you're into that. I somehow like OOP for this type of projects. But you can do it if you want. There's no reason why you couldn't. Yeah, you can do that, but then the object is undefined. So here, if you do like if you debug in the console and you get flag, this has a type. It has the type flag here. If you're just gonna define an object here, like say, and then initialize here all the things that you would do here, like particles and whatever, or left width, height, these kind of things. Something like that. You could just write everything in this kind of form, but then another flag doesn't have the type. And I find that when debugging, making classes like this. Okay, the real reason I do this a lot is because I used to be a Java developer, and somehow a lot of the practices from there stuck here, and JavaScript just allows so many different ways of doing the things that I feel comfortable with these, but you can write the same code a bunch of different ways. Okay, so let's say that we are happy with this 30 width and separator of 10. I guess it's fine for now. So I'm able to change these default values from here if I want from outside, or I can just remove them entirely and then depend only on the probably I still need to pass here. Yeah, I still need to pass an empty object as a parameter, but then the values from here are getting used as defaults. So maybe I just stick to these values from here. Okay, so particles are there, but they are not moving in any way. And that's what we need to implement next. So I'm going to implement this gravity for the particles first. And for that, I'm actually going to need to have some support here in the math file. If you've watched my videos from last week and 2 weeks ago with the vectors, that I'm drinking water, then those are the functions that I'm going to implement. So add 2 vectors or points. I think we don't need to use the polar representation, so just these Cartesian is fine. So we just work with x and y here, no really complicated things. Something like this. And the same for the y. These are essentially utility functions that instead of writing everywhere v1x plus v2x and v1y plus v2y, we can just call add of those two and we get the result. And this is going to really help us along the way when implementing this effect. So let's have similar for subtract. And scale. We want to scale a vector with a given scalar. This is just a number, the second part. So let's write this as v dot x times the scalar, and y is v dot y times the scalar. Like that. And we also need, I think we also need the magnitude. We also need normalization probably. I don't think we need the dot product. So essentially everything from last time. So let's add here to get the magnitude of a vector. And this just is the hypotenuse. So if you think about vectors as how they are, like if this is the 0, 0 coordinate in the top left corner, and then your point is somewhere down like this, and somewhere right like this. So it's gonna be at this location. Then to get its magnitude, to get its length, that's the magnitude, the distance from 0 to x, it's the hypotenuse in this right angle triangle that you see here. So this distance up here that I'm drawing is, I can draw it down there as well. So this hypotenuse here is what we get as the magnitude. So we need the difference on x and the difference on y, but because this is 0, 0, that's how vectors are centered, we just get x and y. X minus 0, y minus 0 is 0. So here the magnitude will just be the hypotenuse of v dot x and v dot y. Let's add function to normalize a vector. So this means we are gonna get its length to be 1, no matter what the original length was. This is gonna be useful, and we do that by dividing its values by the magnitude. So the new x is gonna be, we already have the scale function here, so we scale it. Yeah, we don't need to go x and y here, we just scale the vector by 1 divided by the magnitude of the vector. So this is the normalization function, and I think this is it. Probably we don't need any more vector functions for today. Let's see. And here in our particles, we can start to implement a way to update these locations. So a way to move them according to maybe some gravity. Yeah, let's define the gravity somewhere. And I'm going to define it as a global variable. Here, g is equal to on x nothing, and on y something, maybe 10 on y. So I'm implementing g as a vector, and I'm not using object syntax for this. I don't want to go overboard and implement a vector class. Maybe I do in the end, who knows if you think I should, but I'm doing this combination. So sometimes I'm using objects that have a clear type, sometimes not. And the reason for that is really, who makes functions like add, subtract when you have plus and minus? So it's kind of hinting that if you have functions for doing operations like that, it must be about vectors. I mean, in my mind, it's totally clear that these are vector operations. Plus and minus would do different things. The typical subtraction. Me, mathematics. Well, I did research in machine learning for 10 years almost. So you can't not have mathematics for that. And I do know a lot of things that I'm not doing in the videos, but the YouTube channel is mostly for fun. And when you have really, really advanced things, they stop being fun when you don't understand them. So I somehow like to keep it to an easier level, because I can't just assume that everybody knows a lot of things and then make a video where absolutely nothing is understood. So sometimes I add a little bit more math, and as you guys get better with some of the things, then I can add even more complicated stuff. But I like mathematics a lot, and sometimes I do math related videos. Yeah. Mm. Yeah, for coding with Radu. So, yeah, let's continue. We have now some vector operations here that we can use in our particle class. The meaning of life? I don't know. I think it's beyond my level of understanding the world. Yeah. Mm. I will do some more. So I'm working now on this new machine learning course. It's going to appear in January, I'm quite sure. And that one will have a little bit more advanced math, but I will start off simple. It will be kind of like a more of a software engineering type course, and then the machine learning part comes a little bit afterwards, after we have a system in place. I don't want to teach machine learning just the math part of it. I want to build a real system that works and not just play with existing libraries. So we'll also implement the methods to study machine learning. But I will implement more basic variants of each of the models. So the math won't go overboard. Somehow I want to keep it as friendly as possible, and I think many people are just scared of too much math, and it's true. When you skip some parts in your studies and then you don't know one block, it looks like magic, like complete nonsense. And I want to somehow teach machine learning with the bare minimum of mathematics that you need. Okay, so let's move this particle from this location and then with respect to this gravity. We also have to consider the past location of the particle. So this is how Verlet integration works. It essentially calculates the difference between the old location and the new location each time. And this allows you to have complex things, like if you interact with the particle in weird ways, like maybe it's affected by gravity, by wind, by you playing with the mouse or something, and then it ends up in a new place, you can still use the old location and figure out its movement, its instantaneous movement. So we don't store a property here for vector. We store two properties for velocity. We store two properties for the old location and the current location. So now in our update method, let's just call this update. I'm going to get the velocity by doing subtraction. So we subtract between this location and this old location. So this would be the velocity of the particle. In the beginning, both of these are the same, but as this is changing, they will start to differ. And now to this, with this velocity, I can calculate a new location. So let's say new location is going to be Let's use const and say add to this location the velocity that we just defined previously. But can I now, this returns another vector object. So now I think I'm going to add again the gravity. So not like this, no, it's becoming messy. I don't like this syntax. So let's add the gravity like this. So we are adding first here to the current location, we're adding the velocity, and then to the result, we're adding the gravity. And this is now the new location that we are going to update our location to. But before that, we need to keep track of the old location. So this old location is equal to this location, and this location is equal to new location, the one that we just calculated. So this looks maybe a little bit cryptic, but let's see if it works. So I'm gonna refresh. It doesn't work, but that's because we are not updating these particles yet. So in our flag here, let's actually make an update method for the whole flag. And I'm gonna copy this for loop, but here just say update. So each particle updates, and then each particle gets drawn. And in our main file, I'm going to tell the flag before we draw it to update like this. And this is going really fast down, so let's just put this gravity to something very small, maybe 0.2 on the Y. And you can see what happens when I refresh, maybe even smaller. Maybe even smaller, 0.01. So it starts off slow, but then it gets faster and faster and faster. And that's how gravity works. So if I'm going to go back here and see what's happening, this velocity is the difference between the previous location and the current location. Now, when you add gravity to this difference, you make it bigger. So the new location is going to be farther away than just that difference. Now, when you update all location and new location, you essentially preserve that new difference. So in the next step, this adding the gravity, which is fixed, to the same difference here that has been updated, it's a little bit bigger this time, it essentially looks like we have implemented gravitational acceleration. So gravity accelerates things. It makes them go faster and faster until they hit terminal velocity. But I'm not going to bother with wind and friction and these other things here. Salut, Paul. Constantin David. Okay. And other people, hello, Tesla, and something I probably cannot pronounce, so I'm not going to try. So, yeah. And thanks for watching. Okay, so we have the gravity implemented, and really this could work also. Like, let's see, maybe we have to implement at some point the wind as well. But at the moment, we just have these particles that are going down, and let's combine them, let's link them, And let's keep the first particle here static. So somehow we create a multi-pendulum because one of the particles is static. We're going to need that to attach it to the pole. And then the others are just going to be like pendulums going around. So when defining the flag, I'm going to say here this particles of 0. Let's put an attribute for this, maybe fixed is equal to true. And in the particle class here, I'm going to say this fixed is false by default. But if we change it to true, or let's say here fixed and false by default, like this, because now we can change it also when defining the particle to begin with. So we can set it earlier, later, like I'm doing here, I'm setting it afterwards, but I could also specify here particle with true or false, and this might be useful in a later case. Or let's actually do like that. So fixed is gonna be if I is equal to 0. So the first one here, I is equal to 0, it's gonna be true. And now I can do it here. So about 3 ways of doing the same thing. Maybe this is the nicest one. Yeah, so if the particle is fixed, then it won't update. If this fixed, it's not gonna do anything. Or if this is not fixed, then let's do all this movement here. So the first particle now stays there. Essentially, it doesn't move inside of this update. The update doesn't do anything because it's fixed. It's not going to move from that location. And the next step, we have to merge, to link those particles. And we're going to preserve the distance between those particles, so it never changes. And when gravity will affect, it's going to cause that kind of pendulum behavior to happen. So let me go here on index.html and start to implement a class for segments. These will be kind of like sticks. Some people call these sticks in between the particles, keeping them always at the same distance from each other. So the segment class, it's a empty class for now. And let me just start with some basic code here so we don't get an error anywhere. And the constructor will be between 2 particles. Maybe I'm gonna call this particle A and particle B. So always a segment will be defined between 2 particles. Let's store these in attributes of this. Like so. And we really want to record here what is the distance between these particles. That's going to be the length of this segment. So let me put here length. I wonder if this is a reserved word, because you have array length and things like that. So maybe someday I'll do Fourier series drawing. Are you thinking about this signal processing, or why do you want to see that? You want something like the fast Fourier transform, or? Let's calculate here the length between these by just doing the distance between the locations of those 2 particles. So we are going to need to implement a function for this in our math class, in our math file. but the distance between this particle A location and this particle B location, this is the length of this segment when it's going to be implemented. So when it's going to be instantiated, I mean. And here function distance between 2 points or 2 vectors, it's the same thing because again we are using the vector Cartesian representation here. The distance between these may be so they start at 0 but their tips are at different locations, and here you would need to do the difference, so implementing the Pythagorean theorem here. Or you can actually reuse the functionalities that we have here, so you can use subtract to get the difference. So we can have here subtract v1, v2, and then you can just return the magnitude of this difference. So it's a way that we can reuse these existing functions to implement the finding the hypotenuse using Pythagorean. I have a video about that one as well, but now the top left corner is not 0, 0, so it's between 2 different points. They can be anywhere, so subtracting them gives us something with the 0, 0 in the base of the vector, the tail of the arrow, if you think about them drawn as arrows. So yeah, this function should work for the distance between these 2 particles. And let's try to implement these segments to instantiate them in our flag between the particles. So somehow I want to do this. I can do it afterwards, after I'm done with the particles, and say for let I is 1, I'm going to create the segments here as well. So segments, an empty array, and here we'll say this segments push new segment between these particles of I minus 1 and these particles of I. So we are connecting the particles so that we connect consecutive ones together. Previous to the next, previous to the next. So this should work, but they are not going to affect in any way. They will just exist. So if I'm going to go here and write flag, I should see here 20 particles, but only 19 segments. And we have segments between first particle is fixed. So we have true there. And then second particle like that. And the second segment will be between this particle here and the next one, and so on. Okay, and the length between them is actually 14, because that's how our separator was defined in the beginning. So we also know that our function here for calculating the distance works. Okay. Now, let's keep it from, let's draw them first and then keep them from changing. So I'm gonna have here again a draw method with the ctx context, and let's just say begin path. Let's set the fill style, or let's just leave them, I mean stroke style, let's just leave them black. I don't bother with this, it's gonna be only for debugging anyway. So ctx move to A particle location and line to B particle location. So this particle A location, this particle B location, and align to, oh, sorry, no, this particle A location X and Y, particle A location Y. So we're moving to the particle A location, and the move to accepts X and Y, and we line to particle B location and ctx stroke. So now when I refresh this, it doesn't work because our flag also has to draw all the segments. Let's do it before the particles, so the particles are on top. Segment of this segments, and then segment draw on the canvas with the canvas context. What? Why doesn't it work? Oh, line 2. Now it works, but this one is stretching like a lot, and that's what I don't want to happen. I want all of them to keep from stretching, to stay at the same length, and that's the thing that I need to implement next in the update from the segments. So segments are also gonna have an update function the same way that the particles have, and let me prepare here that it will happen. Segment of segments, segment update. So our update method here will be a little bit more complex, but not a lot. So let's see. We essentially have a length that we want it to have and a length that it has at the moment. So you can see here, this one has a longer and longer and longer length than what we want to have. That 14 needs to stay the same. So what is the new length? The current length. It's the distance between the same thing from here, but with different locations. As time goes by, these particles are going to have different locations, and the one that we created when we constructed the segment stays the same here, the length. But the current length is going to change. If I'm going to log here, we will see here 18 14s and one that is going longer and longer and longer and longer. So the 18 14s are these ones that stay 14, all of those 18 ones. And that one that changes is this very long one. And it's the one we want to snap back into place. So we do that by finding out the vector that connects this point to this point, like just this vector. And we find that out by vector subtraction. So let's say here diff is subtract this particle A location, this particle B location. And now I can find out, I can normalize this. It's going to make things simpler. So I'm going to normalize this distance. It means that what we preserve from this vector is essentially going to be just the direction of the vector, and the magnitude is going to be 1. So it's going to be a unit vector here pointing in this general direction. So let's say normalize the difference. And this normalized difference, I want to now scale. I mean, this is a vector here. I want to scale it by the length, I think. Yeah. So let's just rescale this vector to have the length that we desire it to be. So this is going to be the new scaled version of this initial vector between the two particles. So now I have that, but what do I do with that? No, this is not going to work. Okay, new plan. I added the breakpoint to visualize this. So this here is a vector starting here and ending here, or all vectors actually start at 0, 0. So you can think about it as an arrow going like this, but it preserves this difference, this magnitude and the direction. So that is diff. Diff is this whole vector here, but it's actually positioned at 0, 0. So that's how all vectors are considered. Then normalize, this norm, is the same thing at 0, 0, but it has been squished down to have a length of 1 pixel. Now, what I want to do with this point right here is actually move it somewhere in the middle here, and this point right here needs to move somewhere up here so that the difference between these 2 points is gonna be 14, or our initial length, the one that we defined. So they are gonna move down this line and up this line by some value. And it's actually half of the difference between this whole length here and this 14 value there. So here I want to calculate first, like, what is the delta, this offset that I want to move this point down here, this delta. It's going to be delta, the difference between this current length and this length. So this just gives us a value that is this value, and then the length is the remaining part there. Let's just keep it like that. This part I'm not explaining very well, but hopefully you will get it if you play with the code afterwards. And now I scale this not with the length, but with let's actually remove this part here and start moving the points. So this particle A location is going to be add this particle A location with half the delta. So scale our normalized vector with half the delta. Yeah. And same thing for particle B. But this one I think needs to be minus. So one of them goes down the line, other one goes up the line. So we need to go half the delta in different directions. And this should work now. Let me remove this breakpoint. Okay, something works, but this point is not fixed anymore because we are moving it. We are moving it by force, so to speak. So we need to check here and fix this problem somehow. So if this particle A is static, wait, we called it differently. We called it particle fixed. Yeah, this is fixed. If particle A fixed, what do we do? If particle A is fixed, we actually have to move particle B with the whole delta, not just half the delta. Else, if this particle B is fixed, it could be that we have multiple fixed particles, then we move particle A with the fixed delta, but in the negative direction. And else, this means that none of them are fixed, then we do what we have at the moment here. So this part of code from this else statement is applied between all these particles that are not fixed at the bottom here. This part of code is only between this particle and this particle because particle A is fixed in this first segment, and this part of code is never applied because we never have a B particle that is fixed. We could have, so if for example I'm going to fix the last particle here, then we are going to have in the flag here, let's say fixed if the I is 0 or if I is equal to width minus 1. So I'm gonna fix both of them. Then we just get this kind of effect going on. I could also put here something like one eye in the middle that is going to be fixed, and now we have this kind of functionality going on. It looks like a little bit of slow motion, so I'm actually going to go here and make the gravity more. Yeah, this is kind of what I'm aiming at. Yeah, but I didn't explain this quite well. I am going to make at some point a video about Verlet integration, and I will explain this better. I really need to visualize all those vectors and break at each part of the animation to show you exactly what I mean by this delta value and what this difference vector looks like, how it looks like after normalizing, how it looks like after scaling. I'm gonna make a nice visualizer for this someday. But the thing is that when you practice with these things more and more, your visualizer is not necessary. It becomes part of your brain. You visualize these things without needing to visualize them, and that becomes a problem because you start to not be able to teach those things, because I know what's inside my head, but I cannot show you what's inside my head. So I need to make some explainer for that, and it's probably going to be similar to those videos like where I teach you about segment intersection or vectors, trigonometry, Pythagorean theorem. So it's a kind of like a fundamentals thing about Verlet integration. I will do this someday. So it's called Verlet integration. The method what we're using here, if you want to search this on your own, you can do it. But yeah, I like this, how it looks like at the moment. Let's go back to our flag. And here at the top, I'm going to remove this check. So I only want the first point to be fixed there. And let's actually move this code. It starts to be messy here. I'm going to have a function here generate flag. And this code is going to go in there. It's a private function, so only this object is going to be able to call it. We don't call this from outside. And this width, left, separator, all of these things, they should be passed down here, right? So width, let's just pass everything. Left, top, width, height, separator. And here I just destructured them like this. Let's see if this still works. Yeah, this still works. And height is not used now, so that's what we need to do next. We are generating here particles for this one string, so to speak. And if I'm gonna do more for loops, this becomes complicated. So actually what this code is doing here, it's generating a string. Let's call it that, but string like or let's call it chain, because string can mean like sequence of characters in computer science. So let's not talk about that. So let's say here generate chain. We won't need the height for that. And this generate flag is doing this generate chain with left, top, width, and separator. By this width, I actually now mean number of chain components. So it's a little bit not so well explained, but I'm gonna go with this. So let's put a comment here. Width means number of particles on x-axis, and the same thing for the height. So but on the y-axis. So we have a chain generated like this with the left, top, width, and separator. This generate chain, let's not use the particles, the global particles, but have here a local particles that we are gonna populate with this chain. This is gonna make the code much simpler in the end, because wait, I'm doing stupid things. So let's keep this local particles here. It's gonna make the code much simpler in the end, because this generate chain here is going to be reused vertically. So here I want to return particles and segments, and here I'm going to add these particles and segments returned by this method to the global values. So I'm going to say this part. Okay, let's put here the result object, or let's destructure particles segments is equal to this generate chain, and now I'm going to affect the global ones and say this particles is equal to this particles concat particles. I think this is what I want to do. And same for the segments. So if this works, then I'm happy. It seems to work. So this generate chain is giving us particles and segments from that chain, and we are adding them to the global particles and segments. Now I want to do this multiple times, depending on the height. So let I is 0, I is less than height I plus plus. We are going to call all of these things and generate multiple chains and add all of their respective particles and segments into those global ones. But the y this top is going to be a different y. So const y is equal to top plus the same thing we did here, but vertically. I times the separator. And I have an error. Or no error, but weird things started to happen here. I still refer to this as the top, so top y. So the y value is the top plus I times the separator. We generate chain. Let me remove this log. It's making debugging very difficult here. Oh. I think it was working, but the logs were somehow complicating things. Okay, so what we did is this part right here, generate flag, is now a sequence of generate chain calls with different y values. That's it, pretty much. And it's going off the screen and I don't like it. Let me make the width smaller as well, maybe 15. Maybe the height can be 8. And oh, I'm still logging here. I didn't. Okay, I think some problem with the cache. I forced the refresh and now it seems to work. So this is now something. It seems to be okay. But I want there to be some wind that keeps the flag going that direction. So what I'm going to do now is basically add another force into our globals here. A wind, and the wind is going to be towards the right, something like this maybe. Nothing on the vertical axis. So in our flag, actually when we move our particles, it's the only place where we need to consider this. We also have to add our wind here. So add the wind to all the other things. And this is why I don't really like very much JavaScript. Because in other languages you could use operator overloading for this. So you could write something like W plus G plus this lock plus vel in one line, and not this mess that becomes hard to read. So JavaScript doesn't have support for operator overloading. To make a vector class that has those things, those possibilities, and I really miss it. Miss those things from other languages. So now see what happens. This wind is keeping this flag going only towards the right direction. But I could change it. So if I'm going to change here W in the console, X, the X value of the wind, if I'm gonna set it to minus 0.1, all of a sudden the wind changed direction and it's now pushing it other place. If I'm gonna set it to plus 0.1 again, then now it goes back that way. And the way I'm gonna make this realistically happen is from time to time, I'm just going to change this wind a little bit. So I'm going to say here, wind.x is equal to math linear interpolation between 0.01 and 0.2 with a random third parameter. Oh, I didn't have an object for this math, I just had linear interpolation. So every time I'm going to call this code, it's going to change the wind a little bit randomly between 0.01 and 0.02. If I want it to go in all directions, then I can make this change here, like from minus 0.1 to plus 0.1. Maybe this is a little bit nicer. Sometimes we're gonna get these negative values, sometimes positive values. Every time I'm calling this, it's a change in the wind direction. So what I will do is actually move this flag to the center. Let's put this flag to be the center of the canvas, so that's 250. Let's also lower the gravity a little bit. So maybe this can be 0.05 here. And this code that I have here for changing the wind, I'm going to use a set interval function here. So I will say set interval function every 1 second. I'm going to change the wind to a different random value like this, between -1 and 1. So originally it's 1, but now it's going to change. Every second it's going to be a different wind. And this is what gives it have a little bit of a more organic feel. Now, what I did in the original version, I'm quite sure, is I connected these vertical particles as well with segments. So I did that. It makes this effect a little bit less. This is not very natural what you see here, because each of these strings are independently animated. And because the forces on all of them are the same, it means that they are all going to be exactly the same. But in practice, top part of the flag is going to pull on the bottom part of the flag a little bit, and then everything gets messed up in real. And actually here you could see at some point these start to no longer be symmetric. Like now it started doing some crazy things, and this has to do with the way floating point numbers are represented in the system. And at some point inaccuracies start to build up. Like when you do calculations, you don't have infinitely many precision points, and this crazy stuff starts to happen. So we actually do need to connect these things vertically as well. But it's not very complicated. I think with the new code structure from here, it's going to be quite easy. So, or I don't know. It's not that easy. Let's make a function here. Let's make an object here, an array for chains, and have multiple chains at first. This will make the code nicer. Chains, an array. And what this will do is we just push a new chain to this chains array at first. And we don't do this yet. So each chain that is pushed into this array has particles and segments that we could connect to this result. I mean, add concat to this result. Let's do it here where we let's do it by iterating through the chain. So for each chain in chains, I'm going to, let's actually destructure here particles and segments and add these like that. No, of of here because I want the value, not the index. For in gives you the index. So this is just the same as before, but now because these chains exist separately, I can loop through them. No, let's just get the first chains of 0 and looping through its particles. First chain particles. Chain 0 particles. Looping through these particles from 0 to their number. I'm going to connect vertically with segments. So what I'm going to do next is add a new segment. Segments, push, new segment between this first chain particles and the second chain particles at the same index here. So okay, and now I would need the second chain particles, or let's have another for loop here. From 1 to chains length j++. So this one is going through the chains now, and I make a new segment between not the first chain particles, but the chains of j-1 particles of I. This is really hard to explain, but I think I'm doing correct things. And the current thing. So it's very similar to what we are doing here, where we are creating a new segment between previous particle and the next, but now we're doing it between the same particle index of the previous chain and the current chain. So we start at 1 so that we have a previous chain always. And this should work. Let's refresh. And it doesn't work. And the reason is I don't know. So chains going from 1 to the length. From j minus, so this should exist. Why doesn't this work? Let me refresh and put a breakpoint here. So chains are here. They have particles and segments. And here This should work. And it works. It works until it doesn't. Oh, I have here j less than chains dot length was missing. So this chain's length just was responding true all the time. So this j was increasing past the length of the chain. Yeah, and another error. Okay. And the same thing I did here for I, actually. I forgot that. Okay, so now this flag looks a little bit different. It has these, it looks like a grid now, because the whole thing that we did in the last 5 minutes is these vertical segments connecting it. And one thing I remember doing last time when I implemented this is I only kept fixed this top particle here and the bottom particle here. So those things were fixed and the other ones in the middle were not. So here where we are generating the flag, we generate different chains. Let's have a parameter here for fix first particle. By default, we set it to false. And here, if this and fix first particle, then it's gonna be fixed. But here where we generate the chain, we are going to go through all the items and fix first particle will be if I is equal to 0 or I is the height minus 1. But let's just try it with I0 and see how it looks like. So now when I generate the chain, I want to pass also this value here. Refresh. So now the only point that is fixed is this one, and this looks like some crazy stuff going on there. Hello, yes, coding with me, but unfortunately I don't think anybody could keep up with all the mess that I've been doing. Now I'm happy with the code, but there have been a lot of backs and forths, so if you really want to follow along, you have to probably rewatch this later and do the same things step by step. So yeah, okay, crazy thing, but let's put here also or I is equal to height is equal to height minus 1. So now these 2 points are the things that are fixed there. And this looks decent. I'm quite happy with this. Okay, final thing that we need to do is this colorings. Oh, and let's see if we can even do the colorings with this, because I mean the width and height needed to be some specific salut. The Milky Way boy. Okay. So the colors, doing the colors is gonna be tricky. The width needs to be divisible by 3 because Romanian flag colors are 3 of them horizontal. And but the Finnish flag is different. It has that kind of cross, and I need it to somehow have enough rows horizontally. Okay, let me go in the flag here, and after drawing the particles and the segments, I'm going to put a breakpoint here. A refresh. So I need this to be a multiple of 3. And I also need... Is this a multiple of 3? What is my width here? It's 15, so it should be fine. No, it's not fine. It should be 16 because I will color the segments, the in-between, these kind of patches things. So it needs to be 16 because then there are 15 of those. So that's fine. But then can I find here enough space to... Yeah, I think I can draw the Finnish flag here. So I'm also going to need to put this section blue for the cross shape. And then vertically, for the Finnish flag, I need to be able to divide in the middle exactly. So I think I need one more on the height, maybe 9 here. So let's remove this breakpoint. Yeah, so this should give me exactly what I want here. I think this wind is just very crazy, so maybe my function for changing the wind should have a little bit less impact here. Let's write here wind impact. Wind max impact. And this is going to be minus that plus that. And now I have a way to control this, how strong it is. I think impact is the wrong word here. So let me rename this to max wind strength. Okay, so let's begin to style the flag. And now these will need to be width and height need to be... This is not correct here. I think it needs to be 10. Needs to be multiples of 3 plus 1. So 3k plus 1. Particles, there is no particles.js. This is just our code. So particles is implemented here. I did it in the very beginning. So all of this code, I will make it public at the end, probably on my website or on GitHub. Let's see. Well, because implementing this in 3D, even in 2D, in 3D, you have to somehow deal with more issues like the Z dimension, all of these math functions here. They would need to have the Z component as well. then when the flag moves in 3D space, you have to worry about collisions and checking intersections between lines and planes. It adds to the complexity, and I just found out that doing this in 2D, it looks good enough, and I wanted something that looks okay, not that respects all the laws of physics. So to simplify, I just didn't want to make something too complicated when I noticed I don't need to do that. Well, I have a Discord server on my channel, and you can join that if you want. But it's not just about JavaScript. It's in general about problem solving, I think. But I do most of my tutorials in JavaScript. So yeah, that's one community, and you can ask other people there if they know others. I'm not really expert on those. Okay, so styling the flag. Okay. So our generate flag function here, really, it just creates these chains. Right. I don't have access to these chains anymore. I just have this bunch of particles in the end. But it would be nice to have these chains as well as object here, because it keeps the things organized in a way that I'm going to use to draw the colors. So let's return these chains here. It's just a reference to the particles, so a little bit extra memory, but not a problem. I think the code still works now. So we generate the flag, and now here when we are drawing, let's style the flag. So we are gonna say for let's go through the chains vertically. So that's gonna be Y offset. I just named this looping variable Y here because it's more intuitive. The vertical component, Y is 0. Y is less than, no, Y is 1. I want to start with the second row first. Y is less than this chain's length, Y plus plus. And now horizontally, X is the same thing, I think. X is less than this chain's of Y length, X plus plus. So this thing here, our for loop, Y starts with this 1 and 2 and 3 and 4. So it skips the first chain. It just goes through all of these ones. And X starts here. So essentially we loop starting with this point, going X like this towards the end and Y like this towards the end. And the reason why I'm skipping these previous ones, these other points, let's call these A, B, C, D, is because I'm gonna have this square to color in the next step. So A, B, C, D, we have A is equal to X, Y, like this, but then B is equal to the same X, but Y is going to be Y minus 1. And I started at 1 so that the other one exists there. and then c is gonna be x minus 1, y minus 1, and d is going to be x minus 1 but the same y here. So these are my a, b, c, d points for each of these squares. And this is where I'm going to draw now a polygon between them. Yeah, I don't use prettier because it adds a lot of spacing horizontally, which I like when I read, but it makes my code go off screen often. And the problem with that is I also use a large font size here because I want the tutorial to be easy for you guys to read even on small screens. So that combination makes my code often go off screen. And if it goes off screen too much, you can't read it unless I also move this. But I may not move this when you want me to do it. And somehow too much of this is also not good. So I intentionally don't use prettier because it makes everything somehow more readable, even though I do understand that you guys like these spaces. So it's a conflict I have, and maybe someday I'm gonna use that. But thanks for pointing it out. I am considering changing my practices. Okay, so let's draw this. Context begin path. Let's move to a.x, a.y, and now line to b.x, b.y. Let's have c.x, c.y, and d.x, d.y, and then ctx, close path, going back to A, and then ctx fill with some color. Let's ctx fill style, let's do it RGB A red, and with some alpha here. So just to see if this code works so far, and it doesn't, I have an error somewhere. Assignment to a constant variable. Oh, how can I change these? They're changing, they are updating, and const values don't change. Why doesn't this work? So this was supposed to show some red things here. Oh. No, this is not good. I'm not getting, I need to get the particles from the chain. So the chain has particles, and then the particle location of the chain. So actually, let's just put here underscore x is going to be, this is so annoying. This is gonna be really annoying. So this chains of x, of y and x dot no. I think this is correct, and I hate it. So B is the one with y minus 1 here. C is the one with both of them minus 1s. And D is the one with just that. I hope this works, but I am not a... Yeah, this seems to work, so it's red now. It makes sense about prettier, but I do use prettier when I code my own things that I don't intend to be watched by other people. And I also use a smaller font size for those. Well, there are benefits to using const when you don't want something to change. I think also memory-wise, JavaScript, not memory-wise, but there are some optimizations that JavaScript does. So as much const as possible you can use, it's gonna run faster, but it's probably negligible. So yeah, if something doesn't change, then use const. So the chains are made of particles, and I'm iterating through the chain particles here, which is just horrible. I could extract some of these things, but because the y and x index of these changes for A, B, C, and D, I can't really write a nicer code in this way. So it's kind of ugly here, but it will have to do. So now this is red here. I actually don't need well, it takes a lot of practice to write code, to write good code. I think I can still improve my coding. Oh, really? Maybe you have too many points or whatever. I'm talking about Abdul. But about the skills, it just takes a lot of practice. I've been practicing coding for like 20 years. So you probably have practiced for far less than that if you're asking those questions. So, Mahdi, the answer sounds sad, but it's not nothing really else but practice, practicing and checking good practices, asking people how to do this better if it's bad. I've just done it for a long time, and some of these things feel natural. Okay, but let's keep the color of these individual pieces somehow as well. Um, the chain that we create, we need to have two colors here, one for the Finnish flag and one for the Romanian flag. So when we generate the chain, these patches here, this A, B, C, D, maybe here let's create these as so-called patches. So patches, an empty array, and each patch will have A, B, C, D points. Now I'm gonna take out this code from here, and I'm just going to say here for patch of patches, let's do this. And instead of patch, I'm going to say here A, B, C, D, destructuring. And this code actually doesn't need to be executed because these are references. This, we can move it up here. It's going to make it much more efficient. So it could be what Abdul is talking about. It's doing unnecessary things. So after we generate the chain, we say patches is equal to generate patches. So it's going to go through the chains and return patches. So a little bit reformatting the code here, and we call this generate patches. It's using the, well, we could actually pass this chains here as a parameter and just use chains here, generate the patches for what? It makes more sense. And our this here can go away. And this is quite good because somehow the code becomes a little bit shorter and it becomes more readable in this way. And our patches are generated just when we construct the flag. They are references to the particles locations. No, they are not, damn it. Because these are values like raw data types like numbers, and these won't be stored as references. So let me keep here just the particle for A. I'm doing refactoring here and it's a little bit confusing probably, but it will make the computation much faster. So going a little bit back and forth here. And since some of you are commenting about the complexity, about the code efficiency, let's fix this. So now our patches have particles that are sent to them. These will work because they are references. Okay. And when we are drawing here, when we say of this patches, we have to get, these are particles. So particle A, particle B, C, and D. We get a location.x, a location.y. Same for B, C, D, like this. Wow, I can't believe this works. But far less computation. So the patches are generated in the beginning. They contain particle references here. So as they change in the update method here, their locations are different here. And here we're just drawing these patches. And this is where we can now more easily, when we push this, we also define a color for these. So color of this patch is going to be let's actually use this code from the early beginning that generates random color here. So color is going to be, no, this was red, and then color is going to be this, different amounts of red. And now we pass this color to the patch as well. So our patch will not just have A, B, C, D, but also a color. And when we are drawing the patch, we are setting here the fill style to the color, which we need to destructure here as well. So see how this flag turned into a different Apache flag. It kind of reminds me of kilts, like Scottish people have those kilts, and this is kind of like the pattern for those. So different shades of red here. Okay, the English language. Well, optimization, you will see a video I publish around Christmas. I already made it, but I need to edit it. I will talk about time complexity. I will talk about code optimization also there. And when you start to optimize, really optimize, then the readability becomes a problem. We are not going into that in this one. It's still very readable what we're doing here. But if you try to optimize more and more, it starts to be more complicated to understand. And you have to somehow balance these things out, because if the optimization is not very impactful, then maybe readability should be preserved so that the code is easier for your teammates to read. And then tell about npm package 3.js. Well, this is one thing that it's not 3D, but it can be extended to 3D quite easily if you make the vector operations in 3D and add a Z component there. You also have to implement a way to visualize perspective. So this is on that track. If you're understanding what I'm doing here, then converting this into 3D, even without 3JS, it's relatively easy. Maybe someday I will make a tutorial on 3D perspective. So building things like this, you also understand how those packages work. I use 3JS quite a lot. And yeah, Abdul mentions you can use it without NPM as well. NPM is just a node package manager if you're using. But anyway, so let's continue this. It's not done. We just have random red patches there. The idea was to generate Romanian flag and Finnish flag. So let's start with the Romanian flag. And here I'm going to remove this. Maybe still commenting out. It could be interesting to use. Maybe we get some interesting effect. But the color will be, let's start with Romanian flag, because the Romanian National Day was 5 days ago on the 1st of December. And today is Finnish Independence Day. So that's why the flag choices. And I have both nationalities. So that's the reason for this. So let's say here the color will be changing red, yellow, blue, yellow, red for the Romanian flag. So for the x values less than a third particles length, so color is x is less than then we say blue. Otherwise, x is less than, particle length divided by 3. Then chains of y, should have copied this. 2 times this length divided by 3. Then let me put this syntax a little bit better. I'm using this ternary operator here. I don't use it that often, but for some reason I chose to use it now, even though it has this even more complex situation. So this is now yellow. And finally red, something like this. So if I refresh now, we get the Romanian flag there. And you can see a problem here. Sometimes some patches are drawn on top of others. This is a problem because we are working in 2 dimensions, and it's kind of like a trick. I used the trick in that trailer video from last year. I essentially let this thing play until I found a moment, a long enough moment, where there are no intersecting problems. And in that way, I exported only that part of the video that looked good. So it was somehow me, even though the system is not extremely robust, it's good enough to make a video like that relatively convincing. And if you want to make it look even better, you could consider drawing this with some alpha, with transparency. So maybe here where we're doing this, because if the flag is transparent, then it's okay if some patches are behind others, even though it doesn't make sense, because then you still see through them, the other ones. So you could put here CTX global alpha is equal to maybe 0.3, and you can set it back to 1 if you want to still draw these segments and particles from previously. But now when the flag is transparent like this, let's remove these segments and particles. So when the flag is like this, if it's transparent, those parts where the patches overlap, they look naturally darker, but also it makes it harder visually to understand, is one behind the other one or not? So somehow transparency helps with the effect. It's not a real 3D flag. We don't consider complicated things like what happens when the flag hits itself. Now it just goes through itself. But it's convincing enough that even with this kind of simplified version of code and physics, you still get something that looks quite nice. And let's do the Finnish color pattern as well. So let's call this raw color for Romanian flag color. And now let's do the Finnish flag phi color. And this is gonna be more complicated, I think. Let's start with the horizontal blue line. So if the y is less than chain's length, no, if it's greater than chain's length by 3 and less than 2 times chain's length divided by 3, then we say blue. Otherwise white. So we start off easy. Okay. Oh, it doesn't work. Why is it gray? So if y is more than Chain's length divided by 3. Probably this should be in parentheses, otherwise no. Oh, no, it doesn't work because this phi color, we call it color where we are drawing. And the background here is white, so the white part doesn't appear. Maybe we try a light gray instead. It's visible now, but I don't like it. I think white should be white. Maybe we make the background color of our canvas. Sky blue. So we have the horizontal line there, but the vertical one is also needed. So I'm going to go here and hello basic coder. I really don't know if it's related to the educational system. I think that we teach, we focus on teaching a lot of mathematics, and somehow the math logic can sink in from that, and then you can use it in coding, but I don't know if we teach coding that well, to be honest. Because coding changes all the time, syntaxes change all the time, and in my experience, Romanian educational system tends to teach old things. And you may learn how to code something in some old language that nobody uses anymore. So it's a lot of things that you need to practice by yourself if you want to become good. And again, that math logic is useful. But many coding jobs, you don't have to do so much math there. Okay, so what I want to do here is keep both of them. Color, let's put it as an object raw, and this is raw color, phi, and this is phi color. And now we are going to pass this color here as before. And here, we start off with the Romanian flag color. So each patch is going to have a selected color. Let's say the Romanian one, like this. And when we are drawing these, color of selected color. Oh, I forgot the vertical line in the Finnish flag. But now the benefit here is that if I'm going to go to the patches, like flag, patches, let's take the first patch and put here selected color phi for Finnish. This topmost patch is now white. I don't know if you can see it, but it's white. It changed into the Finnish patch color. I can do more of them to be more visible here. Let's take the second patch also and the third patch also. And you can see here the flag is gradually changing. Yeah. Let's say for patch of flag patches, patch cell color is Fi. And all of it changed to Finnish with this code snippet. But it's not yet the finish. Let's finish the color here. So if this is that, then blue. Otherwise, same for X, I think, but like that. So otherwise, if X is less than, and not that, not so much, because if we do this exactly, so X is greater than chains of Y particles length divided by 3 and X is less than 2 times that, then also blue. Otherwise white. So a long line here. I think I can put it on multiple lines like this so you can read it. So now if I refresh this and change to the Finnish color, it doesn't work. I'm expecting to see the vertical line coming. In the middle. Oh, 2 times 2 multiplied by that. So let's do it again. And now this looks like the Finnish flag a little bit more, but yeah, I can't show you without changing this selected color to Finnish and refreshing many times here. So it needs to have a thinner strip and more towards the start. So I'm just gonna play with these values here and say that if X is more than length by 4 maybe, yeah, and less than maybe that, yeah, we are there. Perfect. Okay, right, so let's start again with the Romanian color pattern like this. We can change it to the Finnish pattern like this. But in my video there, I use some kind of effect for doing that. So my trick is I use timeout function, and we set the patch color to the Finnish patch color like this, but with the timeout that is random. So math.random multiplied by maybe how many seconds you want this to last. So if the transition is going to be 2 seconds long, then put something like this there. And if I type this, you can see those patches changing to Finnish like that. And if you want this code to turn back as well, then you have to check what is the previous color here. So maybe something like, if the selected color is Finnish, then change it into Romanian, otherwise change it into Finnish. So now it's there, and if I run this code again, it goes back to Romanian. And let me put this functionality here. I'm gonna add in the body maybe a button. And let's have a function for this. All right. And let's put this button somewhere in the middle. Let's see. Button. It's the only button here, so. Okay, position, absolute width, no, left 50%, top maybe 20 pixels. I want it to be in the middle, so maybe margin minus 50%. I don't know if this fixes it. No. This works. Yeah, thanks, Adam. I noticed it just now. But you noticed it really quickly. Yeah, okay. The flag is translucent because it helps with patching a problem I have here with my flag, that I'm not handling collisions in 3D space, and sometimes parts of the flag are behind other parts that you don't want them to be. So if I make this opaque, it doesn't look good. There are moments when weird stuff happens. Sometimes. It's hard to find when it happens, but yeah, so in my original video it wasn't translucent, but I just waited for a long time when that problem wasn't happening. Okay, anyway, this seems to look okay sometimes, but I prefer this translucent version We can put this alpha to higher, maybe like this. All right. Anyway, let's try with a little bit different number of patches. So as long as these values are multiples of 3 plus 1, I think we should be okay. Let's put a smaller separator here, maybe 4. So this gives us a small, tiny flag there. And with this small one, the impact of the wind is also much more strong. So this, let's say multiple of 3 plus 1, that would mean like 31, for example. Okay, there's a stretchiness happening here. This is actually part of how this Verlet integration works. It's kind of a problem. I could make it more rigid. We try to make the segments rigid, but when we affect segments one after the other, affecting one segment is going to destroy the fixing we did on another one. So yeah, okay, yeah, flex is another option. So there is some stretchiness happening there, and let's see if we need to fix that. But let's set the height also to maybe what is multiple of 3 there? So 20. Maybe 25. Yeah, very, very stretchy here. But we are getting less of that pixelation happening, because now the separator is just 4 there. So this is fine, maybe. Let's try the color change effect. Okay, and this stretchiness. So to fix this stretchiness, I think we want to do this few more times, this segment update. So hard to explain now, I'm getting kind of tired, but repeating this maybe 10 times is going to give you more rigid behavior. So you see now it doesn't stretch as much as before. Yeah, the higher the value, the more rigid each individual segment becomes, but also more processor intensive your code is going to be. So yeah, maybe we put the separator a little bit higher, maybe 5. Larger value. You start to see a bit of that pixelation happening because of the patches becoming a little bit too big. But I'm fine with this. And the wind is something I don't really think it's a big problem. It's fine. Yeah. Okay. Somebody mentioned shaders in the beginning, and I'm not gonna do that, but maybe one small tweak I could do. Depending on how squished the patch is, we might tweak this color. Let's see if this is... I remember doing this. It's probably the last thing I did when implementing the effect last time. So here we are putting a fill style. We are coloring this with the selected color. But I was coloring it again. So I used another fill style which was just black, but transparent black, and then the alpha was computed somehow. I was looking at how squished this object is, this quadrilateral is, and I computed a version for how squished it is depending on the ratio of its diagonals. So the distance between A and C ratioed to B and D, I think it was. So let's say here one diagonal 1 length is distance between A location and C location, so this is one diagonal, and then diagonal 2 length is the distance between B and D. And now this ratio, we can calculate the ratio between these. But to get this ratio between 0 and 1, like what our alpha values should be, I'm taking the minimum of these. So like that, and the maximum, I hope this works. And it wasn't more complicated than this. I really don't remember. So dividing minimum by maximum should always give us between 0 and 1, and if this minimum is equal to maximum or very close, it should be 1. So I want opposite of this. I want opposite. I want if the rectangle is really facing us, so somehow it looks like a square, these diagonals are equal, then the alpha should be 0. So this is 1 minus ratio. And otherwise, if it starts to face away from us, I'm making it darker. So yeah, and I'm drawing another fill again with this new color. So this is somehow, and probably it's not a good idea to go all the way to full black, but let's just see what we get here. And refresh. So it's not fantastic, but it makes it look a little bit, let me remove this alpha here. So it makes it look darker when those rectangles are more skewed somehow. But this amount of darkness is so much that it's too bothering. It's bothering me too much. You can see here sometimes nearby patches have different elongation, so to speak. If we give this a name, like call this elongation, then this ratio. So instead of having this value between 1 and 0, we can actually use lerp here. So interpolate based on this ratio. So this was 1 when it is maximum. I think we want to do here something like 1, no, 0. Maybe 4, 0 ratio. Yeah, so this seems to be similar as previously, but it never goes to full black. It goes in the worst case to 0.4. It can be even less. Sometimes this effect is, I mean, it's sometimes better not to, sometimes less is more, basically. Yeah, I think I'm pretty much done with this, and I liked the transparent version of this more. Maybe a little bit translucent. Yeah, I'm not a big fan of this styling of the patches now, darkening the color there. I think it can be done better, maybe taking the elongation of neighboring cells as well. But I'm done for today, so this is gonna be it. Maybe it actually looked a little better without this. It's now a little bit bothering me how those nearby cells are affecting each other too much when that kind of shading is appearing there. Okay, so this was it. Maybe the gravity is too high. I'm going to put it lower so that the flag doesn't go down as much. Or let's just leave it like this. And then the wind strength, maybe this can be a little less. So color changing still works. Yeah, that's it. So hope you liked this. Any last minute questions? It wasn't so much of a step by step kind of following along with me kind of thing, but I think the steps should be clear and they are very well explained if you watch the whole video, maybe afterwards, twice the speed or whatever you feel comfortable with. But this is good. I think it's less than 3 hours now. So any last minute things? If not, then I'm gonna end the stream in 1 minute or so. Oh yeah, and in the original video, so the way I did the overlapping, so two things I did there. So overlapping with the real video, I did it by using a green screen. So the green screen was essentially the background of the canvas. So something like this, and then I did the green screen removal for that in post-processing. And I also did that weird thing where I did the spider webs that moved the stretched the canvas, stretched the thing. That was actually done with mouse movement. So I was clicking on the screen, detecting the clicks, figuring out which is the nearest particle, and then fixing it to my mouse location. Let's try to do this real quick. I think, yeah. So, of course, that I did without recording the mouse cursor, so it just matched my movement in real life. And then the spider webs, I have another tutorial for that. It's in the description. But I think I triggered those spider webs not in the same way as in the video in the description, but I told them where to appear programmatically, like hard-coded where are my hands in that moment. So, okay, real quick, I'm gonna try to do this mouse interaction as well. So let's go back to sky blue because we don't do any green screen effect today. I just mentioned to you how that part was done. And quickly here, event listener for the mouse click. So I'm gonna put here also a variable for if I'm dragging or not, because I want to be able to drag part of the flag with me. And here I'm gonna say mouse x is event.x, mouse y is event.y, this parameter.y, and here I'm gonna say mouse is dragging set to true. So this is gonna be another event listener here on mouse move. And this is gonna check if dragging, then do something. So what I want to do here is get nearest particle to mouse location. Let's have it a global. Selected particle. And selected particle is the nearest particle from the mouse location. I'm not gonna bother with some thresholds for that. And we are going to say selected particle fixed is true, and every time we move we say selected particle location x evt.x, and same for the y. Actually we don't need to record the mouse anywhere, and we can just keep is dragging as a global variable here. So I'm gonna put here is dragging set to false and make it changeable. This is like that, and this is, we can pass the whole event there. And here, if it's dragging, we are going to say that. And all the things that we need now is this get nearest particle to a given coordinate. So this is going to be a new method added to the flag. So to a given location, and we're going to say, let's calculate the min distance. Max safe integer, I think this is part of the number. And we're gonna loop through all particles. So we are gonna calculate the distance between our location and particle location. If the distance is less than the min distance, then min distance is the distance, and nearest particle Oh yeah. Let's add a mouse up also. And set is dragging back to false. So now I'm grabbing the flag. I'm grabbing the flag, and when I release, it stops. And it actually adds here another fixed point. So something like this is what I did with the spider webs there. So now the wind is affecting this, but it's kind of like a sail. It's affecting very little because it's fixed in different parts, but you can see a little bit of movement there. And of course the color change effect still works, but and you can add many of these points, but I added just a few of them. So this is now the full story of how I did that effect. And yeah. Oh, if I click exactly there, I can reshape these actually. It's kind of nice. This starts to look a little bit like the bat logo. Maybe I have to change from Spider-Man to Batman or something. All right, that's really it for today. So later in the description of this video, you'll see a link to where you can get the code. And thank you all for watching. See you guys. Yeah, maybe it's the Canadian leaf. But anyway, so this kind of interaction there with the mouse is also now possible.